Hi guys, welcome back. We're on Module 5, Lesson 16, problem number 5. You should have your module books in front of you right now, working right alongside me. Last lesson, we were together identifying trapezoids, and this lesson we're together drawing trapezoids. And number 5 asks you to draw a very specific trapezoid, and we're going to do that together. I have included here some images of different size trapezoids. One thing that we learned about trapezoids is that they all have 4 sides. So they all fit under that umbrella of quadrilateral shapes, quad meaning 4-sided figures. And the other thing that we identified about trapezoids was that they always have one set of parallel lines. So these 2 lines are parallel, 1, 2. But these aren't. These aren't parallel. You can see that they would eventually intersect. They would run into each other. These 2 lines are parallel, but these aren't. And then these 2 lines are parallel. So a trapezoid always has 2 parallel lines. Now, I've included a drawing or a image of a protractor tool because we're going to use it again today to help us. I want us to be thinking about a couple of terms that are going to come up in this module lesson. One of the benchmark angles, that means really critical angles that we see not only in this lesson, but all the time in geometry, is a 90-degree angle. That's what I'm drawing right now on the protractor tool. A 90-degree angle is a benchmark angle because we use it to estimate the size of other angles. So a 90-degree angle is very easy to see. If you stood up right now and you pretended that your hands were a clock, you could put one arm facing up towards the 12 and another arm straight out towards the 3, and this would be a 90-degree angle. Or you could switch it and go to 9 o'clock, okay? One hand straight up towards the 12 and the other facing the 9. That's a 90-degree angle. I've got a picture frame right in front of me, and the corner of the frame makes a 90-degree angle. Behind me is a window, and the corner of that window is a 90-degree angle. Got a sheet of paper in front of me as well. The corner of that is a 90-degree angle. So you see them all the time. But if I wanted to find, say, a 55-degree angle, I could go, all right, 55 is just about half of 90. So if I make my 90-degree angle and then I close it almost halfway, now I've got an angle that looks like this, right? It's going to be, if this were a clock, this would be 305, okay? And we see that on our protractor as well. That's a 55-degree angle, this guy right here. All right, and we're going to be asked to make 55-degree angles right now. So let's do that. Oops. I've drawn the points, or I've labeled them already. This is point A, point B, and point C. They're asking us on our final trapezoid in problem number 5 to draw a line segment that's parallel to the bottom of this page. It's 5 centimeters long. If you have a ruler, great. If you don't, that's okay too. The size of this, the length of the side measures doesn't matter so much. Just make sure you draw, following their directions, a line that is parallel to the bottom of your page. This will be angle A and B. This is line segment AB. And now you're going to connect that, making 55-degree angles right here. So check this out. This line that goes up towards point C, that angle right there is a small angle. That's about 55 degrees. This would be 90 degrees, but this is 55. We're going to connect it. Oops. We're going to connect it from B to C. And then it says, draw a line that intersects B and C. That's parallel to line AB. And now you've drawn your trapezoid. Look, inside of here, all of this is your trapezoid. Congratulations.